let's look at just a couple of more basic examples for a vector with 3 dimensions. Just filling in a couple of little gaps from this beginning phase. We're going to go a lot deeper into vectors and into 3 dimensions as the unit moves forward and as the course moves forward. But I need you to have a couple more little pieces of basics in our toolkit to use. So first example, here are 2 vectors in 3 dimensions. And we are going to find the resultant, or what we get when we add vectors u plus v together. And this is as simple as just adding the matching components. So by writing it, the 2 given vectors this way, it's pretty quick and easy to do this. 7 and 2 would be 9i. Negative 5 and positive 5 is 0. Well, my pre-algebra teacher says I don't need to write that. I think my physics teacher would be okay with that. And then 1k, remember there's a 1 here, minus 4k, that's going to be minus 3k, and oops, they forgot their hats, which is not always required, depends on your professor. So you could write the resultant as 9i minus 3k. Now, this is where the teacher in me and the student in me, we have different opinions. I disagree with myself. The part of me that's going to grade your paper says, that's fine. The part of me that's trying to teach students who are less experienced with vectors suggests maybe you need to remember that there's a 0 in that placeholder. All of you computer science majors, that array that you're going to have your answer, your components filled in, that array is going to have a 0 there, and it's not blank. This looks like it's not there at all. So you have to remember that there's a 0 term. But it does say or, and I really am not bothered by the IJK notation at all. Now, another sample. Again, these are just quick and easy little cases here. So let's suppose that vector u is identified by 17, 3, negative 8, and vector v is identified by the vector negative 17, negative 3, and positive 8. If we were to find the resultant here, or u plus v. Now here you have to decide what notation you're going to use. So in component form, you would see 0, 0, 0. What do you write if you want to use the IJK notation though? What is the notation for a vector with all 0 components? Well, this is written as what is called the 0 vector. If you write the number 0 here, you will be marked wrong. 0 is a number. Remember, 0 is real. Check your wallet. If you have no money, 0 is real. It's how much money you have in your wallet. 0, the vector, is like a single point. It has no magnitude, but it may have a direction, like you're sitting in a chair facing a direction, but you haven't gone anywhere yet. The 0, the vector. If you want to calculate the magnitude of the 0 vector, well, with all 0 components, you don't have a choice but end up with 0, the number. Remember what we called it? If it's not a vector, our initial values were called scalars. So this is 0, the number. This is 0, the vector. They are not exactly the same. And I wanted to make sure you've seen that, plus a couple of other little practice pieces before we move forward with vectors. Until next time, have a good one.